Okay, in this class we will discuss the next concept, that is the irrational number. Irrational number. So these irrational numbers is denoted by the symbol q bar. Usually we are denoting the rational numbers with the help of q. Irrational numbers we are denoting with the symbol q bar. Okay, so this is the rational number and this one is the irrational number. Then what is the meaning of irrational number? How you can define the irrational number? As you all know that the rational numbers, what is the definition of rational numbers? The numbers which can be represented in the form of p by q or a by b or c by d. In that p and q are integers where q is not equal to 0. It means the denominator of the fraction, it is not equal to 0. So this is the definition of rational numbers. A rational number is the number it is represent in the form of p by q where q is not equal to 0, and p and q are the any integers, whether it may be positive integers or negative integers. Now come to the concept of irrational numbers. If we are representing the rational numbers in the form of p by q, means the irrational numbers we cannot be represent in the form of p by q. So how we can define the irrational number? The numbers which cannot be represent, we cannot represent in the form of p by q, where p and q is again integers and q is not equal to 0. We cannot represent the irrational numbers in the form of the p by q. So these type of the numbers are called as irrational numbers. Okay, so take some examples for irrational numbers. First one, all non-perfect square numbers. All non-perfect square roots are irrational. What is the meaning of this statement? All non-perfect square, root 1, root 2, root 3, root 4, root 5, root 6, root 7, root 8. Here you are having some perfect square numbers. Okay, what is the square root of 1? 1. Square root of 1 is 1. We cannot write exact number of square root of 2. Square root of 3, square root of 4 is 2. Square root of 5, 6, 7, 8. So non-perfect squares, 2, root 3, root 5, root 6, root 7, root 8. So these type of the numbers are the examples for irrational number. Okay, the non-perfect square, all non-perfect square. Root 9 is the rational number, because what is the value of root 9? 3. 3 can be represented in the form of rational number. 3 by 1, 2 by 1, 1 by 1. Okay, so all the perfect squares are rational numbers. All the non-perfect square, other than perfect squares numbers, for example 1, 4, 9, 16, 25, 36, 49, these are the square numbers, right? Square of 1, square of 2, square of 3, square of 4, 5, 6, 7. So other than these numbers, all the numbers are considered as a irrational number. Okay, so all non-perfect square roots are irrational number. Next one, second one, all non-perfect cube roots are irrational number. So all non-perfect cube roots, cube root of 1, cube root of 2, cube root of 3, cube root of 4, cube root of 5, next cube root of 8. Listen here, you already studied in the previous classes square and square roots, cube and cube roots. What is the cube of 1 cube value is 1, 2 cube value is 8, 3 cube value is, we need to multiply 3 times. Cube means we need to multiply the given number 3 times. Okay, so 3 cube is 27, 4 cube is 4 4s are 16, 16 4s are 64. 5 cube is 125, 5 5s are 25, 25 5s are 125. Okay. So other than these numbers, here cube root of 1 is 1. We can represent in the form of rational number 1 by 1, because we already know that the denominator of any number is always 1. Cube root of 8 is 2. Cube root of 8 is 2, right? So 2 by 1, it is in the form of rational number. It is in the form of rational number. So cube root of 8 is also a rational number. Other than these numbers, other than non-perfect, other than perfect cube roots, perfect cube roots are considered as rational numbers. Non-perfect cube roots are considered as irrational numbers. Okay. Next, third one. All non-terminating and non-recurring. All non-terminating and non-recurring. It means if I am writing 0.2222, this dotted points indicates it is a recurring number, whether it is recurring in the single digit or it repeats in the single digit or in the length of digits or period of digit. We already discussed in the previous classes, right? 0.45, here 5 is repeated. This bar indicates, the bar line indicates the 5 will be repeated in the next sequential. Okay. Next, sixth one, 0.2525. Here 2525 repeat in the next sequential order. So these type of the non-terminating and non-recurring numbers are called as irrational numbers. These are also examples for irrational number. And one more important, the fourth one is pi is a irrational. Pi is a irrational. Pi is a irrational number. What is the value of pi? 22 by 7. 22 by 7 is the rational number. 22 by 7 is the rational number, but pi value is irrational number, because when we are finding the value of 22 by 7, we are getting 3.14 and so on. Even we are calculating million of terms, we can, the number will not be terminates. It means 22 will not completely divisible by 7. Okay, so pi is also irrational number. So these are the some examples for irrational number. Now rational numbers, in the rational numbers we already discussed some basic concept. Just recall that basic concept, it will help in the next concept. For example, all the rational numbers when we are converting to its simplest form, its co-primes are, the numerator and denominators are the co-primes. It means it has the HCF of 1. For example, if I am taking 4 by 6, whether it is an example for rational number or irrational number, rational number, no, just convert it to its simplest form. 2 2s are 2 3s are 2 by 3. Now what are the factors of 2 and 3? Factors of 2 is 1 and 2. Factors of 3 is 1 and 3. Is there any common factor here? Yes, 1 is the common factor. So if any two numbers having 1 as the common factor or HCF of that two numbers is 1, then we call it as the two numbers are co-prime numbers. Okay. So in the rational number, the numerator and denominators are co-prime numbers. In the irrational numbers, these numbers are not co-primes. It means we have one more factor that is other than 1. Okay. Next, one more concept. 2 square. 2. If I am dividing 2 by 2, what I will get? 2 divided by 2, which is equal to 1. Just divide the 2 square by 2. 2 square value is 4. 4 divided by 2 means 2. 2 1s are 2 2s are 2 by 1 are, simply we can write it as 2. So it means if any number, I am considering that number as a, if A is divisible by 2 or 3 or 5 or 7 or 8 or 11, 10, whatever it may be. If A is divisible by 2, then the square of that number, A square is also divisible by 2. So these two concepts, the co-prime concept and the divisibility concept, are important to prove the given numbers as an irrational number. Okay, if A is divisible by 2, then A square is also divisible by 2. Then we will take one more example. Second example. Here I am taking 4. 4 is divisible by 4. Yes, 4 divided by 4, which is nothing but a 1. So what is the square of 4? 4 square divisible by, check it, just 4 square whether it is divisible by 4 or not. 4 square is 16 divided by 4, that is equal to 4 by 1 or 4, right? So a is divisible by 4 means a square is also divisible by 4. Okay.